This is SpaceTime, Series 21, Episode 22. Coming up on SpaceTime, a new Australian-developed rocket engine passes a major test. An out-of-control Chinese space station to fall back to Earth in the next few weeks. And scientists are getting to know Steve. But it's not what you think. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Gilmour Space Technologies has carried out a successful test of its new G70 rocket engine. The orbital-class single-port hybrid rocket motor successfully achieved 70 kilonewtons of thrust, that's 15,700 pounds, during its latest test at the company's Westmar facility in Queensland. The Gold Coast-based startup's founder, Adam Gilmour, says the test brings the company a step closer to its goal of launching low-cost satellites into space. Gilmour envisages his launch vehicles carrying payloads of up to 400 kilograms into low Earth orbit by 2020 using the most fuel-efficient hybrid rockets ever built. The majority of commercial launch vehicles today use either solid or liquid-fueled engines. Gilmour's hybrid design combines a liquid oxidizer with a solid fuel propellant. The advantage of hybrids like this is that they allow the rocket motor to be throttle controlled. That's the primary advantage of liquid-fueled rockets, while at the same time still producing far more thrust, the primary advantage of solid-fueled rockets. The company began testing hybrid rocket engines in 2015, using both nitrous oxide and hydrogen peroxide, together with high-density polyethylene and high-density polyethylene wax blends. It's worked closely with the Singapore University of Technology to develop a novel multi-material fuel-grain printer that supports the direct production of a composite solid fuel pellet. The company is planning to use its hybrid rockets for both suborbital and orbital flights. Gilmour says his hybrid rockets are simpler and cheaper than liquid or solid fueled systems. But hybrids have been notoriously difficult to scale up, resulting in relatively poor engine efficiency and performance. Gilmour believes that problem's now been solved, following the successful test firing of a 46-centimetre diameter single-port hybrid rocket motor, while still being able to provide throttle control from 10% up to 100% thrust performance. He says the G70 engine is now ready for its suborbital test flight slated for later this year, that is, pending launch approvals from the Australian Federal Aviation Authority. The company made news recently, signing an agreement with NASA allowing them to test their new robotic Rover, which is designed to extract water from the red planet, at one of the space agency's Mars yards.
Well, we're a space technology company with a primary focus on developing a small satellite launch vehicle, which will have the ability to take 400 kilogram small satellites up into low Earth orbit, which is where the industry is moving towards. And there is plans from large companies to send more than 6,000 of these small satellites into low Earth orbit in the next 5 years. So we think we're well placed to provide a good service to them. And earlier on in our life cycle, we did a lot of other space technology work around life support systems.
We've just seen in New Zealand the Electron company do their first successful space launch, and they intend to launch something like 2 satellites a week.
Yeah, I mean, they've done very well, and we're very proud of them. They're pioneers, but there's different classes of satellites, and a lot of satellites are small that are like 50 kilograms or 100 kilograms, but a lot of them are 200 and 400 kilograms. And the vehicle that Rocket Lab's developed doesn't have the capability to take these slightly bigger satellites into orbit. So we're not super worried about them as a competitor. And even if they could take the same, there's so many satellites need to be launched that all the current launch companies that have got decent amount of traction, that's still not enough to take all these satellites up.
So how far along are you?
Well, Sounding Rocket, we're almost ready to launch it. We're going to be about 3 months from now, we'll launch a sounding rocket, but that just goes up into space and comes back down again. And then we believe we're around 2 years away from launching an orbital rocket. We're quite a way along on that.
Do you have a name for your rocket yet?
Yeah, we call it Eris. ERIS.
Cool. And what made you think of that?
Well, I like to name rockets after objects in space. Most people do, and most of them have been taken already. But Eris is a companion moon out near Pluto, and we liked it because it's a long, long way away, and our ambition is to travel to the stars eventually. So it was a nice object that's a long way away that we can shoot for. And we found this later, but it's also the goddess of strife and discord. And I like that name as well because we do want to shake up the launch industry with our rocket. We're right in the middle of testing our main orbital engine, and it's been quite successful so far.
What can you tell us about it?
Well, we've got a pretty cool technology. It's called hybrid rockets, which is very different from what the traditional rockets have done, which uses either two liquid propellants or an all-solid propellant. And both of those have a lot of explosive risk, whereas because a hybrid rocket uses one liquid and one solid, they're in two different phases of matter. They can't combine together, and therefore they have zero explosive risk. They're also very simple to operate, and the only problem that they've had in the last 60 years is people have had problems with the fuel. It is either burned too quickly or too slowly. So we did a lot of research and development on finding the fuel that worked really, really well. And we have successfully tested quite a large motor. I mean, to put it into context, the motor that we're testing has almost 4 times the power of Rocket Lab's main orbital engine.
That's their Rutherford engine there.
Exactly.
You guys have got an agreement with NASA.
Yeah, it's called the Space Act Agreement, and it's basically an agreement about collaborating with NASA. And I want to be very clear that when we collaborate with NASA, we have to pay for NASA's time and use. And it's not expensive. You know, they give us very good prices that are transparent and commercial. But we're very excited about that because NASA has a lot of different divisions that do a lot of work on things that we're interested in, and we really want to collaborate with NASA, and this agreement gives us the ability to collaborate with NASA across many of the technologies that NASA's working on.
You're going to be using one of their Mars yards?
Yes, well, we did a bit of a roadshow 2 years ago where we went and visited a few NASA centres and talked about all the different technologies we were working on, and the team that was very interested was the Mars exploration team that's in Kennedy Space Centre, and they have a very big Mars yard with a simulated Mars surface, and that's where they said, why don't you bring your rovers over and you can test them on this in this yard and we can see how they work.
That's Gilmour Space Technologies founder Adam Gilmour. And this is SpaceTime. I'm Stuart Gary. A report by the European Space Agency warns that China's Tiangong 1 space station is now expected to re-enter Earth's atmosphere on its uncontrolled descent sometime between March 30 and April 6th. ESA says the space station's re-entry could take place anywhere between 43 degrees north and 43 degrees south latitude. That places most of the world's major population centres in its path, including Sydney, Brisbane and Darwin, as well as New York, Chicago, LA, Hong Kong, Athens and Rome, to name just a few. While most of the 8.5-ton spacecraft is expected to burn up during atmospheric re-entry, some of the larger components, especially those constructed out of stainless steel or titanium, are expected to survive the fiery inferno, making it all the way down to the surface. There are also serious concerns about the possibility of contamination from the spacecraft's highly toxic and corrosive hydrazine fuel supply. At the request of the United Nations, a major international effort led by ESA's Space Debris Office in Darmstadt, Germany, is now monitoring the 10.5-metre-long space station's progress as it re-enters the atmosphere. The problem is the exact time and location of re-entry won't be known until shortly before it begins. That's because the solar wind emanating from the sun is causing constant variations in Earth's atmospheric density at the edge of space. And that constantly changing density affects the amount of atmospheric drag impacting on the spacecraft, which in turn affects its rate of orbital decay. The latest observations we have indicate that Tiangong 1 has now descended below 258 kilometres in altitude. By comparison, the International Space Station usually orbits the planet at around 400 kilometres. Originally launched in 2011, Tiangong 1, which means Heavenly Palace in Mandarin, was China's first orbital space station, allowing Beijing to test space docking capabilities, the reliability of equipment in long-term orbit, and allowing taikonauts to work and live for extended periods in microgravity. Crews from both the Shenzhou 9 and Shenzhou 10 capsules visited the orbiting outpost. It was designed to be a stepping stone to a larger space station and eventually mining bases on the moon. The spacecraft was originally meant to undergo a controlled re-entry, with its rockets firing timed to allow it to burn up over a large unpopulated region of the East and South Pacific Ocean, designated as the official satellite re-entry graveyard. However, Beijing mission managers lost control of the spacecraft in March 2016 when their telemetry link suddenly failed. A couple of months later, amateur satellite trackers watching Tiangong 1 found China's space agency had lost all control over the station. The thing is, it wasn't until September 2016 that mission managers finally considered that they had lost control of the space station. I'm Stuart Gary. You're listening to SpaceTime. Scientists all over the world are getting to know Steve, but it's not what you think. You see, Steve is a strange shimmering ribbon of purple light in the auroral night skies. The phenomenon was first discovered in 2016 by amateur astronomers who decided to name it Steve when members of the Aurora Chasers Facebook group began posting photos of the unusual purple streaks. Now, the European Space Agency Swarm mission has focused on the strange auroral feature, discovering that it's far more complicated than originally thought. The findings, published in the journal Scientific Reports, shows that while Steve can appear at the same time as an aurora, it's a very different beast. Auroras form when Earth's magnetic field guides energy and ionized particles in the solar wind following a large flare or coronal mass ejection on the Sun around the Earth and towards its north and south poles along magnetic field lines. When these particles collide with atoms and molecules in the upper atmosphere, they light up in spectacular waves of luminous curtains known as the southern or northern lights, the aurora australis and aurora borealis. Auroral activity usually lights up in greens, blues, browns, creams and reds, depending on which interactions are taking place, and they can last for hours on end. But Steve is very different, a purple streak which is only visible for a relatively short time. While Steve is created through the same general processes as normal auroral activity, it travels along different magnetic field lines and therefore can appear at much lower latitudes, where the alignment of the global electric and magnetic fields makes ions and electrons flow rapidly in the east-west direction, heating them in the process. The swarm's measurements show that Steve's composed of fast-moving streams of extremely hot atomic particles called subauroral ion drift. Interestingly, scientists have known about this drift for decades, but they were unaware until now that it also had a visual effect. The study's lead author, Elizabeth McDonald from NASA, says Steve can help scientists understand how the chemical and physical processes in the upper atmosphere can sometimes have local noticeable effects in lower parts of the atmosphere as well. This therefore provides a good insight into how Earth's system works as a whole. As for the name Steve, well, it's here to stay, and in true scientific tradition, researchers have turned it into an acronym. STEVE now stands for Strong Thermal Emission Velocity Enhancement. SWARM is an ESA mission designed to study Earth's geomagnetic field. The SWARM constellation consists of 3 satellites, Alpha, Bravo and Charlie. They're placed in 2 different polar orbits. 2 of the probes fly side by side at an altitude of 450 kilometres, while the third probe orbits at a slightly higher altitude of 530 kilometres. The probes produce high precision and high resolution measurements of the strength, direction and variations of Earth's magnetic field, using precise navigation accelerometer and electric field measurements. SWARM's data is used for modelling the geomagnetic field, enabling the composition and processes of the interior to be studied in detail. This is SpaceTime. I'm Stuart Gary. In the wake of growing tensions with North Korea, Japan has launched a new spy satellite to keep an eye on Pyongyang's activities. The new IGS Optical 6 Earth Observation Reconnaissance Satellite was blasted into orbit aboard a JAXA H-2A rocket from the Tanegashima Space Center south of Tokyo. The launch had been delayed by 24 hours due to bad weather. The 53-metre-tall H-2A flew in its basic 202 configuration with just 2 rather than 4 strap-on solid rocket boosters. The spacecraft's been placed into a 500-kilometre high sun-synchronous orbit, where it joins a growing constellation of Japanese optical, infrared and radar spy satellites designed to monitor North Korea's nuclear missile program and the increasing Chinese military influence in the South China Sea. Built by Mitsubishi, the IGS Optical 6 represents a third generation of Japanese spy satellites, with resolution capabilities down to as low as just 40 centimetres. The launch also marked the 37th flight for the Japanese H-2A workhorse. I'm Stuart Gary. You're listening to SpaceTime. A SpaceX Falcon 9 rocket has blasted into orbit carrying a new Spanish military Earth observation satellite. The PAZ spacecraft, together with two SpaceX demonstrator telecommunications satellites, lifted off during the dark early hours of the morning from the Vandenberg Air Force Base in California.
Falcon 9 is on internal power. Vehicles in self-align.
AFTS is launch ready.
Falcon 9 is in startup.
LD, go for launch.
15.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Pitching downrange. Stage 1 propulsion is nominal. Power and telemetry nominal.
The Falcon 9 as it ascends through the atmosphere carrying the PAZ satellite to a polar sun-synchronous orbit. Right now the rocket is approaching what we call max Q. This is the point at which the aerodynamic forces in the rocket are at the greatest. The Falcon 9 actually throttles itself down as it passes through max Q and then throttles back up once we're through it.
Vehicle has reached maximum aerodynamic pressure.
We just passed through our maximum aerodynamic pressure, max Q. That Falcon 9 rocket is now throttling back up full speed as it ascends through the atmosphere. As that first stage ascends higher and higher through the atmosphere, the ambient air pressure starts going further and further down. Those exhaust gases getting bigger and bigger. We're going to be passing through what we call MECO, which is main engine cutoff. That's when that first stage is going to complete its burn. Shortly after that, we'll have stage separation and then second engine start. That was a good MECO, main engine cutoff, a good separation of that first stage, and then what appears to be a successful second engine start 1. Stand by for fairing deploy. That was a successful fairing deploy. The fairing falling down below the second stage. SpaceX will be attempting to recover this fairing today. As the second stage ascends higher and higher into orbit, let's talk a little bit about exactly what orbit we're going to today. This is a low Earth orbit, polar sun-synchronous orbit. Low Earth orbit refers to the height of the orbit above the Earth, so things such as the International Space Station are also in low Earth orbit, but they orbit more along the equator, which is what's called a low inclination orbit. A polar orbit circles vertically about the Earth with respect to its poles, so that it passes over the north and the south poles. This is the orbit we're going to today. Certain types of polar orbits, like this one, a sun-synchronous orbit, keeps the orbit's plane directly in line with the sun. This allows any satellite that's in a sun-synchronous orbit to see all points of the Earth from exactly the same lighting conditions as illuminated by the sun. This is extremely useful for imaging applications, which would be the PAZ spacecraft's primary intended purpose. Low Earth orbits only require a single burn, so we won't be having a coast phase or a second engine start like we would normally have for geosynchronous Earth orbit launches.
PAZ forms one of the key components of the new Spanish National Earth Observation Program. Built by Airbus Defence and Space, PAZ carries an X-band synthetic aperture radar mounted on a TerraStar X hexagonal carbon fibre platform. The 1,200 kilogram satellite is designed to collect high-resolution surface images day and night and in all weather conditions for the next 5 years. PAZ also features ship tracking and weather sensor capabilities. The spacecraft will be used primarily for defence and security applications, but it could also have some potential civilian uses as well. As well as the primary payload, the flight also carried SpaceX Microsat 2A and 2B, a pair of 400 kilogram prototype demonstrator telecommunications satellites for SpaceX's planned new Starlink satellite internet service. SpaceX plans to do away with all terrestrial internet connections by having up to 12,000 of these satellites in its Starlink constellation. As well as the satellite payloads, SpaceX has also used this mission to test its new upgraded payload fairings. The fairings form the two halves of the rocket's nose cone and are used to protect payloads from aerodynamic forces during launch. The new shrouds are designed to better survive their return to Earth after being jettisoned at altitudes of over 100 kilometres. The fairings will be recovered for reuse on future missions after splashing down at sea. SpaceX believes reusing the fairings will save the company some $5 million in launch costs. I'm Stuart Gary. You're listening to SpaceTime. A Russian Soyuz rocket is blasted into orbit from the European Space Agency's Kourou spaceport in French Guiana. The launch had been delayed by several days, initially for additional technical checks and then due to high altitude winds.
Top 9, 8, 7, 6, 5, 4, 3, 2, 1, top décollage. Deuxième étage du lanceur. Les moteurs des premier et deuxième étage fonctionnent normalement. Bonne stabilisation du lanceur.
In the clear blue sky above the Gilmour Space Center, over the Amazon rainforest, Soyuz blazing a trail. Range Operations Manager is telling us that everything is going according to plan. Everything's nominal. Our altitude, 36 kilometers above Earth. Our speed coming up to 2 kilometers per second. The boosters being jettisoned. They twist and turn. We have confirmation there of separation. We don't need them anymore. The boosters can fall away with shedding weight. We're burning the core stage now. The Block A burns for nearly 5 minutes. Right now we are 78 kilometers high and getting closer to what we call the Kármán line. That's the border with space. It's named after the Hungarian-American aerospace engineer Theodor von Kármán, who died in 1963. And it's where the air becomes so thin that we can no longer support vehicles with wings, and we have to use rocket science to stay up. Everything's going according to plan, and he's confirmed that the fairing has been jettisoned. He's telling us that the functioning of the Block A motor is going normally.
Arianespace Flight VS-18 carried 4 Ka-band O3b satellites. The satellites are being placed into 7,830 kilometre high medium Earth orbits, some 4 times closer to the Earth's surface than geostationary satellites. All 16 OB3 satellites were launched by Arianespace, which will launch a further 4 of the spacecraft next year as the SES constellation continues to grow in both coverage area and capacity. As well as those in medium Earth orbit, SES also operates a constellation of over 50 telecommunications satellites in geostationary orbit. The Russian Federal Space Agency Roscosmos used the Soyuz in its most powerful STB variant, together with the Frigate MT upper stage, for launches from Kourou. The flight was the second launch for Arianespace this year, and the 18th for the Soyuz rocket from the South American Space Complex since the first launch in 2011. It was also the 1,887th launch of the Soyuz R-7 class booster in the more than 60 years that the former Soviet Union's nuclear intercontinental ballistic missile has been operational. You're listening to SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australians call their nation the lucky country, but it may not be so lucky for all. A new study has found that more than 1,600 Australian children are hospitalised every year due to self-harm. The findings, reported in the Australian and New Zealand Journal of Public Health, are based on reports from the first 12 years of the 21st century. The study found 18,223 self-harm and 13,877 assault hospitalisations in kids under the age of 17. Researchers have put together the most comprehensive study ever conducted into the origins of the people of Vanuatu, long regarded as a geographic gateway from Asia into the remote Pacific. The findings are based on DNA analysis of ancient skeletons, modern samples, as well as archaeological evidence. Vanuatu's first people were the Lapita culture. They arrived some 3,000 years ago from Southeast Asia. They were followed by Papuan arrivals from the island of New Britain in the Bismarck archipelago east of New Guinea who have been living in the region for around 50,000 years. The findings, reported in both the journals Current Biology and Nature Ecology and Evolution, suggest that the Lapita people, after arriving in New Britain, moved fairly quickly directly onto Vanuatu and encouraged some of the local populations already in place on New Britain to move there as well. A new study has found that injuries to whales caused by vessel strikes in Australian waters are far higher than reported. The findings, published in the journal Frontiers of Marine Science, shows that a review of archives and government reports suggests that vessel strikes in Australia may account for almost 15% of worldwide incidents, 8% higher than previously reported. In fact, the actual figure may be far higher than that because many vessel strikes are not detected and therefore go unreported. BAE Systems Australia has won a contract to upgrade the Defence Department's futuristic Jindalee over-the-horizon radar network, JORN. JORN provides air and maritime operations, border protection, disaster relief and search and rescue operations, monitoring regions beyond the Australian mainland by bouncing radar off the ionosphere to detect objects up to 3,000 kilometres away. The JORN installations are located at Laverton, Alice Springs and Longreach and are controlled from the Edinburgh Air Force Base in Adelaide. The $1.2 billion upgrade will improve performance by replacing much of the pre-existing infrastructure, including radar and frequency management system hardware, and using newly developed software to keep the system operational until at least 2042. A fresh warning has been issued about a flaw in Microsoft's Cortana assistant. The problem involves a new way for hackers to bypass the login screen on Windows computers. With the details, we're joined by Alex Zaharov-Reut from IT Wire.
This actually came out originally in September 2017, where hackers were using high-frequency commands that were still spoken but inaudible to the human ear, but the microphone could pick it up. So that was an interesting conundrum because this is something that you couldn't personally hear.
This is like those speakers to get kids away from the front of shops, so they play classical music at a higher frequency range that kids can hear but adults can't.
Yeah, and it's also supposed to be the way that you can scare off mosquitoes with these apps that do high frequencies. But that was back in September last year. What's happened in the last week is that hackers have also discovered that because Cortana, which is the intelligent assistant built into Windows 10, if you go into the settings of your computer and go to Cortana, there's a setting called Use Cortana even when my device is locked. And it seems by default this is turned on. And so even though you might have a lock screen, you can still tell Cortana, hey, open up the Edge browser and navigate to a particular website. And if that website has some malicious software that can operate on a version of Windows that hasn't been patched, then it could download malware onto that computer.
That's Alex Zaharov-Reut from IT Wire. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and if you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary. At SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.